IP addresses to all of this router, and I need to enable OSPF to all of this router, right? So let me do that. But before I want to tell you that here the task you also seen that in the screen it implement OSPF to all routers, and R5 should be connect and reach area 0, right? So there is a one rule of OSPF that any physical interface should be connect backbone area 0, must be connect all the links should be connected to area 0, right? But R1 R2 is ABR router, our area border router. We all of know what is the ABR router, but let me tell one more time that ABR is nothing but if one interface is connected to the area 0 and another is connected to the different area. See here, one area is connected to area 0, my R1 and other interface should be connected to the area 1. So this is my ABR router, area border router. So my R1 and R2 is my ABR routers, and ABR is the ability to exchange the LSA type to exchange the routes, okay, to the end-to-end reachability. So here R3 is not an ABR and R5 is connected to area 3. So what can I do here? There is a one concept came up, that virtual link concept. So if any physical interface is not connected to the backbone area, there must be a one virtual link must be connected, must be create, okay. So what can I do? I will create R3 and R1 as a virtual link, because my R5 should be connect and reach area 0. So this router, my 5.5.5 prefix must be learn all of this router and enter its routing table, prefix this 5.5.5. So first of all, let me do enable OSPF to all of these routers, okay. Now go to the R1. Here let me tell you one more thing, that we have two methods to enable the OSPF. One is traditional method that give the router OSPF and the process ID and add the multiple networks, right? So that is the old method and traditional method. But now we are using one more method, that is go to the manually interface and assign the run this command. Let me show you all that what is that command, okay. So here let me configure, okay. See, of R1 we have two interfaces, right? So so this one I show you what is that command. Just go to the interface and send them manually, right? So here go to the F0/0 and run this command IP OSPF, give process ID. Here I'm giving the process ID 100, so make sure that process ID should be same for all of these routers to enable OSPF. And area is 0, right? Our this interface should be in area 0, right? So just run this command, and this is the simplest and easiest method to enable the OSPF, right? Just okay. So what can here do, that go to the interface and enter the manually. We do all these interfaces to go and give this manually and run this command, right? So another interface we have 0/1 and IP OSPF 100 and area. So this area is in area 1, right? That's it. Exit. So now we advertise our loopback address, right? We have one more network, this there 1.1.1. So for that we go to the router OSPF process ID 100, give the router ID if you or if you not, so okay, it's optional, but router ID is a unique ID. It's easiest to identify and learn the prefixes. So 1.1.1. okay, so add network here. What is the syntax of OSPF to add the network? 1.1.1 wildcard mask and area 0. Done here. Okay, now next move to the R2 as well. So the same. So R2 we have okay, so R2 we have two interfaces here. See, one 0/1 and 0/0 and one network. Okay, so enable as well here OSPF. Go to the config terminal, interface F0/1, enable OSPF 100 and area is 0, exit, and one more interface we have F0/0, enable OSPF 100 and area. Which area? Area 2. This interface we have area 2, right? So enter, exit, and now enable the advertise the loopback here. So for that, go to the router OSPF and give the router ID as well. Router ID 2.2.2. Okay, network we have here loopback address to wildcard mouse, area 0. Okay, we're done here. So move to the R3 as well, and here so see here we have two interface. One is 0/0 and another is 0/1. 0/0 is in area 1 and 0/1 is in area 3. So let me do that. F0/0, enable the IP OSPF 100 and give the area. That's it, 1. Okay, so now next we have another interface. We have F0/1 and we enable the OSPF here 100 and area 3. That's it. We're getting the notification. All of you seen this notification right here on the screen right now. So okay, let me advertise loopback network here to enable router OSPF 100. Give the router ID 3.3.3.3, and we have network 3.3.3, wildcard mask, and area should be 1. Okay, done it is. Okay, so move to the R4 as well, and here we have only one interface and advertise one loopback. Okay, so we have interface F0/1 and enable the IP OSPF 100 and the area should be 2. Okay, now exit and advertise router OSPF 100. Router ID, right? We give to the router ID as well. Router ID 4.4.4.4. okay, now network must be have 4.4.4 and exit of wildcard mask we have given here. Area is 2. So done here. As you all see, our neighbor adjacency is forming right now. So yeah, okay, move to the R5. So see, we have to advertise. We have two. One is loopback, another is one interface is 0/0. So let me configure this one. IP OSPF 100, area is 3. Sorry, I'm always in hurry mode. Okay, okay, now exit. So now we advertise one loopback, right? So move to the rotor OSPF 100. We have rotor ID as well, 5.5.5.5 network 5.5.5 wildcard mask, and area is 3. So we done here. Okay, I advertise all these prefixes and form the neighborships, form the agency. So let me show you. Just run this command. We all of see this notification right on the screen. So IP OSPF neighbor. Okay, my R1 neighbor is 2.2 and 3.3, right? So move to the same as well. Show IP OSPF neighbor. Sorry, I'm in config mode, right? Okay. Show IP OSPF neighbor. See, R2 we have 1.1.1 and 4.4.4. Okay, so like this, let me show. This is our R1 is our ABR rotor and R2 is also ABR rotor, and ABR is the ability to move and exchange the LSA types, right? Let me show here. Run this command, show IP OSPF database. Database. Okay, see here. See, this is our type 3 LSA because this this rotor is our ABR rotor. So this rotor have the power. Let us say that to exchange all this LSA and to show the directions to all the routes, right? So see here we have 1, 2, 4, 10, 20. So this is our router LSA, this is our type 1 LSA, this is our type 2 LSA, network LSA. So our network is here, see 10.0, right? This is our network, right, for loopback. So this is our network, and this is our type 3 LSA we have here. See, we have two network actually. This R1 consider a two network. One is 10 and one other is 30. So we have both, right? So this is our type 3 LSA. Okay, clear? So let me show one more thing here. See, move to the R5. I will show here via ISPF database. See, so this router is only form the neighborship to R3 and share this route to R3 only. My R5 router is not able to reach here R1 to the area 0 or R2. Why? Because it is not directly connected to the area 0. There is a rule for OSPF for every router should be connected to the backbone area, right? So what can I do here? For this one, virtual link concept is must be there. Okay, so for the help of virtual link, this my R5 prefix should be reached to the area 0 and learn this 5.5.5.5 prefix to all of these routers and also this ping. So let me show one more thing here. Just ping 4.4.4.4. See, I'm getting the reply, right? This because this R1 is a ABR router. R1 have should this route all these prefixes, but R5 they didn't have. Why? Because it's not connected to the area 0. So what can I do here? I will I do here one I create one virtual link here for R1 as well as R3. Okay, so move to the R1. Let me show you. Okay, here go to the config, just type the interface R1. See, here we have R1, right? Just move to the enable the rotor OSPF. Okay, OSPF 100. Just give area name, which area in R1 should be have area 1, right? So this area should be our transist area. So this area, which area is this? Is our area 1 is our transist area. To move my 5.5.5 prefix to learn this R3 with the help of virtual link, and R3 is moved to the R1 and R1 is our ABR router. So whenever I create here virtual link, R3 should be act as a area border router. Okay, my R3 should be act as a ABR router. Let me write here. This is my ABR. It should be act as ABR router. So this is our area 1 is our transist area. Virtual link, when we create the virtual link, when one of our router should not connected directly to the area 0, so then the virtual link should the help. Okay, it could be help. So okay, there is a one command here for creating the virtual link. Just run this. And router ID, so for which router ID we have to creating here. So for R1 the area ID should be 3.3.3.3. so this is our transist area, right? That's it. Exit. Okay, so move to the R3 as well. Same do here. Just enable OSPF 100. So now area 1. So area 1 is our transist area, right? So that's why virtual link. And for R3, what is our area ID? 1.1.1.1. Exit. That's it. So now our R3 should be act as the area border router. So let me check here, run this command to show you that my R5 5.5.5 should learn, the R3 should learn all this all of these routers should be learning the 5.5.5. Let me show OSPF database. I hope it's visible, right guys? See, now my R3 should learn the prefix of 5.5.5.5, right? See, 1 2 4 5. R3 now should be learning my 5.5.5 because of with the help of virtual link. So move to the R1 as well and check here. Just run this command, show IP OSPF database. Perfect, right? See, now my 5.5.5 should be reached here, so it should be connected to the area 0. So our task is completed. So another task we have, one area, any one area I could be make as a stub area, so it's I will do later, but check the reachability. Okay, so R1 here, ping, now ping 5.5.5. see, I'm getting the reply, right? So move to the R5 as well, and here check all of the prefixes should be entered in the routing table or not. Okay, so database, right? Okay, just relax. I'm always in a hurry mood. See, now my R5 also learning these prefixes 1.2.3.4.10 20 20. All this network should, it is also a type 3 LSA. Now it is because my R3 should be acting as a ABR router. So just ping R1, I'm getting the reachability, right? So this task is over. Now my another task is one of my area I need to be considered as a stub area. Did you know guys what is stub area? Why the area concept should came up? So let me tell you that what is the stub area. Stub area is nothing but it's block the type 5 external routes and it's inject a default routes. Default route is enough to reach outside of any external routes to reach this router. Okay, suppose take this, I have considered that area 3 is my stub area. Okay, let me do this one, that go to the R5. Okay, I'm just considering here because the stub area is we have the multiple area concept, right? Stub area, not-so-stub area, totally not-so-stub area. Why this area concept should become? It's reduce CPU, guys. That's it. It's reduce LSA size, because every router it's considered it's produce its own network, its own LSA, its own link state database. So every route, it should be conflict, right? It's flooding this LSA. So why it is happening, why this area should be come up? Because it's reduce the LSA size. That's it. It's reduce CPU, it's reduce LSA size. Because some let us say one example, there is one small branch office or any remote office, they don't need any external route. They need just a one default route to reach the destination. Okay, to forward the packet, to forward the traffic, they need just one default route. It's enough, because there is no need multiple routes to right, because all the OSPF also is the shortest path calculation, right? It is open short path calculation. It is also choose the best path, right? So for this, okay, so let me show IP route. This is our inter area concept, guys. Here, see, IA means my route. There is our route here. We have all the routes. Every router should be have these prefixes because of OSPF inter area connected. This is our IA means OSPF inter area connected. See here. Okay, all my prefixes should be learned here via OSPF inter area. So now let me do my R5 I am making as a stub area, because I don't want any type 5. It's block type 5 external routes, guys. It's block type LSA, but it's produce only type 1 and type 3 LSA. Okay, it's block a type 5 LSA. And one more thing here, it's inject one default route 0.0.0, and for that route, with the help of that route, it's do any from outside external routes. By using this default routes, it should reach the destination or use this route. Okay, so let me do here, make this task completed as well. Okay, so here enabling router OSPF 100, just make it router OSPF 100, just write area 3 is my stub. Okay, exit. See what we are getting one notification here, the neighborship is down. Why? Because we didn't configure still to the R3, because R3 and R5 is in area 3, right? I can't configure the stub for this both router. So for this, move to the R3 as well, and here also I need to configure, I need to make this area as well stub. Okay, so router OSPF 100 and new area 3 is stub. That's it. So how to check to that area, our area 3 is in stub? Okay, one second. Did you see the notification? Again, the urgency is formed, right? Okay, let me show that OSPF virtual link, show IP OSPF, it's enough, right? So here we will check that our area 3 is in stub area. See, our area 3 is, it is a stub area. Did you see? Right. So yeah, in here also show IP OSPF. Oh, sorry. Okay. Okay. Show IP OSPF. So see here, my area 3 is a stub area. Okay, great. So now show IP OSPF database. Let me show this as well. You see, before um, before make area 3 as a stub, we don't have this root, right? 0.0.0, right? Why? Because whenever we configure the area 3 as a stub, there is automatically it's inject a one default root, that is 0.0.3 via that 3.3.3.3. This is our area thread. So move the R3 and let me show here also. Show IP OSPF database. See, we have here type 3 LSA, we have one default root 0.0.0.0. So for any external roots should be reached by using this default root. Okay, whenever we configure the area 3 as a stub area, it's inject one default root. For that roots, it's the help of that root, it must be reached the any outside external root. Okay, so yes, I did all the configuration here. I done I completed this task. R5 should be connect and this prefix should be reach all of this router, and R5 must be learn all of these prefixes, and its end-to-end reachability is there. So yes, I make one area as a stub area, any of an area, and a stub area I will tell that I tell the what is the difference between why we came up the area concept. Okay, I hope this video is helpful for you guys. So I'm just a learner here, I don't any